Hello students. So in this class we are starting with our subject data structures and algorithms DSA. So in this subject there are few algorithms for sorting and searching, and then there are five major data structures which we are going to study in this subject. About those, I have already told you that we'll be studying stacks, queues, linked list, trees, and graphs. So this is a little bit idea of the subject, what you are going to do in this. So let us start with a formal definition of data structure. What is data structure? So data structure is defined as logical and mathematical model of representing data in computer memory. So you want to store something in computer memory. For that, you will prepare some modeling, logical and mathematical model. That is what we call data structure. But this is a formal definition. आप इसको ऐसे समझ सकते हैं कि डेटा स्ट्रक्चर मेमोरी में डेटा को स्टोर करने का कोई तरीका, कोई मेथड है जिससे आप उसको स्टोर करने के बाद में जब भी आपको चाहिए तब आप उसको वापस इजीली प्राप्त कर सकें. So informally, we can define data structure as method to store data in computer memory such that it can be retrieved easily whenever it is required. So retrieve means to get back. So data structure is nothing but how you store data in a manner that whenever you need it, you can take it back. So one elementary data structure array you have already studied in your C programming subject. So array is an elementary data structure, and data structure is not new for you. So in array what you do, you declares array like this in A10. So by this declaration you are telling that you are going to store 10 elements which are integer. Now integer takes 2 bytes, so this array A will require 20 bytes. Now what happens? Suppose this is your computer memory. See, computer memory is very huge. You only need 20 bytes. But you have, suppose you have a memory of 4 GB, then it becomes total 4 into 2 to the power 30 bytes. That is 4 into 10 to the power 9 bytes. So there are a lot of bytes in your memory. Out of those, you only need 20 bytes for your array. Then what happens that these 20 bytes are allocated somewhere in your memory, and you are some method to access or retrieve those data which are stored here. So how you retrieve in array? If you write A0, then this represents the first element's value. And if write ampersand A0, it's first element's address. Similarly, AI will represent ith element. Say you want fifth element, then you will write A4, that is fifth element, because the index is starting from 0. So in array, that those all things you have already done. Now I want you, because you are computer students, that you must always be aware of the unit of memory. So you use memory as 1 KB, 1 MB, 1 GB. So 1 KB is what? KB is kilobyte. It is 1024 bytes. And this is 10 to the power 10 bytes. It is approximately equals to 10 to the power 3000 bytes. Similarly, 1 MB is 1024 KB. That becomes 2 to the power 20 bytes and approximately 1000 kilobytes. 1 GB is 1024 MB, 2 to the power 30 bytes. So array is an elementary data structure which you have already studied. Now let us come to the next, uh, take this as an informal discussion on data structure, that what is data structure. To get a better understanding, we have like taken some few real life examples. A data structure always have a memory space to store data, and then there are functions to access those data. Functions means you want to insert something in the storage space, you want to delete something, you want to traverse and search. So what are those all functions? This will be more clear to you when you will implement some data structure. So here I take an example. See, this is a overhead water tank. अपने छत पे पानी का टैंक रहता है वैसा टैंक है. अब देखिए अब इसमें होता क्या है, देयर इज अ स्टोरेज स्पेस. स्टोरेज स्पेस मीन्स यू कैन स्टोर वाटर हियर एंड देन यू हैव सम इनलेट. इनलेट आप ऊपर से उसमें पानी डालते हैं एंड आउटलेट, आउटलेट से आप नीचे से लेते हैं. तो क्या हुआ, देयर आर फंक्शंस टू स्टोर, इंसर्ट और डिलीट data from this. So this is a overhead water tank. And when you go to watch a movie and you obtain a ticket from ticket window, what happens, that there is a storage space, means a queue where you can stand up and wait for your turn, and then you get a ticket and you go out. So what happens, somebody goes out, some comes in. So this is a storage space and there are functions to insert and delete. See, so in this manner, if you take this, so this is a data structure which is we call as a queue. So this is a queue where in your data structure there is a separate end for insertion and separate end for deletion. Now see some other example. Say this is a box and I have put some books in this box. So diagram is not too very good, but you can understand that if I put the book inside and if I take a book out of it, then there is only one point of interaction with this box. Means on a single common end I put or insert a new item or I take back an existing item. Similarly, in a marriage, if you watch the dishes, so pile of dishes is there. If somebody is putting clean dishes over there, then he will be putting on top of it. And if you are taking a plate from there, then you will be also taking from top of it. So such kind of structures where there is a storage space and we can access that storage space from a single point from where we can insert new item and can take back an item, then this is called a stack type of data structure. Now you see here is a bookshelf where I can put books horizontally. So if the books, I keep the bookshelves in this fashion, or see this another example where there are coaches of train which are connected to each other, then what can I do? I can insert a new item at any place in between them, or in this also I can insert a new coach anywhere in this train. Similarly, I can remove an item from anywhere. So such kind of structures where it permits you to insert or delete item from any point, those are called linked list type of data structure. See, there are many variants also. In queue, we will be studying priority queue, DQ, and in stack, we'll be studying maintaining more than one stacks in a single storage space. In linked list we will be studying doubly linked list and all, so you don't bother about those things. But the basically what is a queue, what is a stack, what is a linked list, and what is a data structure, so you can always understand like this, that there is a storage space and there are operations to perform. Now let us take the next one. So we'll be starting with a data structure called stack. So stack, how to define it? So stack is a linear data structure in which insertion and deletion operations are performed at one common end called top of the stack. So this is what definition. So you will be defining that stack as a linear data structure. So what are non-linear data structures? What are linear data structure that will be taking up? Linear means the items are linked or stored in a linear fashion. So stack is a linear data structure by definition in which insertion and deletion operations are performed at one common end, which is called top of the stack. So this terminology top, this is important. So you remember it. This is related to stack. Now you see, when we insert something in a stack, this operation is referred as push operation. And when we delete something from the stack, we will call it a pop operation. So in general, we don't say insertion and deletion in a stack. We call it push and pop operations. And this terminology is very specific to the stack only. So push and pop. So push means insert, pop means delete. Now you see here, I have taken this array as a vertical array just to visualize it like a stack. So I can put data here, here, and here, 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 and so on. So integer s10. So I have created a storage space, means this array. So array is a storage space for the stack. Here I have mentioned array is as a storage space of the stack. And integer top equals to -1. So what I'm doing, I'm taking only an index. Index means where is my top. ये एरे कहां तक भरा हुआ है उसके लिए टॉप लिया है. सो इफ टॉप इज -1 it indicates that the stack is empty. So this is, we have our own creation that initially if top is -1 we will consider that stack is empty. Top is -1 is stack is empty. Now see what push means. When we push an item, a new element in the stack, what we do, we increase the top. See, if my top is here and I want to insert a new item, I will go at this place and will put that item here. Then if I want to insert one new item, then I will go here, second position, and I will put the item here and so on. So what we do when we push a new element in a stack, we increase the top by 1 and store the new element at S top, array top element. Similarly, to decrease, to pop, so if I want to remove some item, then what I do, I decrease the top by 1. So top will come 1 point below. So this is what the push and pop operations in a stack. Now see this example, and we are this taking this example to understand how the pop and push operations are working on a stack. So this is like a question. You write this question as a question that show all the steps on a stack when following operations are performed in order on an initially empty stack. तो स्टैक शुरुआत में खाली है, इनिशियली एम्प्टी है. ये सारे ऑपरेशंस वन बाय वन लाइन से करने हैं, ऑर्डर्ड ऑपरेशन है, ऑर्डर में ही करना जरूरी है, ऐसा क्वेश्चन में कहा है. और आपको दिखाना है कि स्टैक की क्या पोजीशन है. नाउ यू सी दिस इज स्टैक एम्प्टी. सो आई हैव मेंशन हियर टॉप इक्वल्स टू -1. मतलब हमारा टॉप तो -1 पे है, स्टैक खाली पड़ा हुआ है, इसमें एक भी आइटम नहीं है, तो स्टोरेज स्पेस खाली पड़ा है. अब हम कर रहे हैं पुश 20. So top becomes 0 and we put here 20. Now we are pushing, next operation is push 30. So now when I will push 30, it will go above it. So this top is now 1. So I have increased the top. So here top is now 1. So it is top is pointing that here is the top element. Now push 40. So top will become 2. So here 20, 30 and 40. So top is here. I have shown this by an arrow. So top is 2 now after doing this push operation. Now if I perform a pop, then see which element will go out? Only the top element, because this is a stack, and a stack by definition, insertion and deletion are performed on same end which is called top. So deletion, we will not ask which element to be deleted. Only the top element will be deleted because this is a stack. So I have mentioned pop only. So pop means 40 will go out and top will become 1. Now if I push 80, push 50, so first 80 will be pushed, then 50 will be pushed and top will become 3 in here. Now I am performing this operation pop. So pop, so this 50 will go out. Similarly, then when I push 100, push 70, push 90, So you are probably understanding that one by one, top will increase. Top is 300 is put here. Top is now 470 is put here. Top is now 590 is here. So in this manner, up to 70 we have pushed. Then push 90. So push 90, push 120. So push 120. Now top has become 6. So one by one we are pushing. Then now it is pop pop. So we will pop 120 first, and then we will pop the second one, that is the uh, 90. Now here comes one concept which is called underflow and overflow concept. This is not only related to stack, but this is related to every data structure which is implemented using an array. So now you see, the underflow concept is always there. We will not say that using an array. We will say in every data structure, the overflow and underflow occurs. But overflow a condition can be avoided if data structure is implemented using a linked structure. So that will be taking up in later classes also. Today we will only basically understand what is overflow and what is underflow. So for this is definition for any data structure when we try to insert a new element in already full data structure. So data structure is already full, and then you are inserting something, it means this is an overflow condition. Similarly, when data structure is empty and you are deleting some item from it or removing some item from it, in case of stack, you will see if you are performing pop operation, then it is called underflow condition. Here is an example, especially for stack. So here, see, I have declared a stack int as 10. So my stack can take 10 elements at the most. So I have pushed items into it, and finally the top becomes 9. So top becomes 9. This is not overflow. This is full stack. Now, if I do one more push operation like push 50, then this is an overflow condition and this push 50 is not possible. Similarly, if my stack is empty, means top is -1. Now, in empty stack, if I perform pop operation, then this is called an underflow condition. So, what is overflow and underflow? Overflow means inserting a new item into a full stack is the overflow condition. And underflow is deleting an item from an empty stack is underflow condition. So I hope that in this class you are familiar with what is your subject about, then what are data structures, and what is a stack. By definition, its operations like push and pop, and how these push and pop works when we implement this or take this stack as an storage space as an array. In next class, we will be discussing how to implement this stack. So we will be implementing stack in two ways using an array, which is called static implementation, and we will also use linked nodes, which is called dynamic implementation. So we will also write the program or will understand how to write a program in C programming to implement a data structure. So wait for my next video. Watch this video properly. Come to the Google Classroom and Google Meet. Assign your attendance uh, before doing the question answer session. So in this video, after seeing it on Thursday, that is today is 6th, so 7th, 8th, 9th. On 9th July, Thursday, 9 a.m. to 9:45 a.m. I'll be discussing problems on this. So you come to the class and Google Meet class, and then assign your attendance first, and then you ask your doubts. Watch the video properly. Remain in touch. Keep practicing. Keep following my advice if you really want to implement the data structures. So next class we will start implementing it. Thank you. Thank you very much.